heat energy or steam energy into mechanical energy. So, therefore, the high pressure steam is fed to the turbine, where turbine has got different blades. So, due to the high pressure of the steam, the turbine blade starts rotating it. Therefore, it converts into mechanical energy. This mechanical energy is transferred to the generator through the some coupling system. So, therefore, the generator starts rotating it. We know the Faraday's law of magnetic induction. By rotation of generator, that is armature, the electrical energy is developed. Therefore, the purpose of generator is to convert mechanical energy into electrical energy. This electrical energy is transferred to the bus bar. Bus bar is nothing but a different feeders. So, through the different feeders, it will be connected to the different switch yards. So, in this, the chemical energy boiler, chemical energy converts to heat energy. In turbine, heat energy is converted into mechanical energy, and in generator, mechanical energy is converted into the electrical energy. This is the simple explanation for a thermal power station. So, basically a coal is fed to the boiler, where in the boiler the heat energy is converted into the steam energy. This steam energy is fed to the turbine, where the turbine converts the steam energy into heat energy, mechanical energy, and this mechanical energy is again fed to the generator, where in the generator the mechanical energy is converted into the electrical energy. This electrical energy is connected to different switch yards. From the different switch yards, it can be transmitted to different areas. So, let us look at the schematic diagram of a entire thermal power station through this diagram. The working of a thermal power station. This is a boiler. It is in the heart of the thermal power station, and to this boiler, from one side the coal is put into this boiler through various stages. This is coal storage, this is coal handling plant. From this, the coal is fed to the boiler. After burning, the coal is converted to the ash. The ash will be removed through the ash handling plant to the ash storage, and in the boiler the water is converted into the steam. That steam is fed to the superheater, where in the superheater the steam is converted into the dry steam with high pressure, that is fed to the turbine. This is the turbine unit. From the turbine, the mechanical energy is transferred through this coupling to the generator. From the generator, it is transferred to the transformer and bus bar and to different switch yards. And let us look about the turbine. After importing the energy, that is steam energy, into the turbine blades, the pressure will decreases and volume of the steam will increase. This is called condensed steam. It is fed to the condenser, and again that steam is converted into the water through the feed pumps. Again it is reheated, it is fed back to the boiler. This is a schematic diagram of the thermal power station. This figure looks like a very big chart. So, I made into 4 stages. Let us see about the first stage of the thermal power station by looking into this picture. So, in this I have taken only boiler. This is a boiler filled with a water, and from one side the boiler is receiving the coal. The coal is transported from the wagons, that is trains, and dumped into the cold storage. This is the cold storage. Generally the cold storage will be in acres, because each thermal power station, if you are considering a 100 megawatt of power station, requires about 20,000 to 30,000 of coal. Just imagine a 20 to 30,000 of coal to deposit, how much area is required. That is only example for 100 megawatt station, but each thermal power station will have about 10 to 1200 megawatt of generators. So, that means 20,000 into 10. So much of coal has to be kept, and this is for one day consumption, but always the coal has to be kept more. Sometimes in coal mines, due to the strikes and so many other problems, the coal may not be receiving. So, therefore, at least 1 month coal storage has to be kept. So, for that a big yard is required. that is kept in cold storage, and from the cold storage the coal is transported to the coal handling plant, where in handling plant the coal will be made into small pieces. The raw material of the coal will be very big lumps, it will be made into small pieces, otherwise while burning the coal may not be burnt completely. Therefore, the combustion may not be perfect. So, it will be made into small pieces by using the ball mills or some screw conveyors, and this pulverized coal or fine powder is fed into the furnace of the boiler, and where in the furnace the coal will be burnt. After burning, the water will be converted into the steam in the boiler at one stage, and after burning the coal there will be a wastage of coal, that is called ash. The ash will be removed through the ash handling plant to the ash storage, and from there that will be stored in tanks. Now, the first stage of the thermal power station is coal fed to the boiler. So, after that the ash will be removed through the ash storages, and in the boiler the water is converted into the steam. And let us see the second stage of thermal power station. The second stage. So, after getting the steam from the boiler, it will be in wet condition, but with high pressure. That high pressure wet steam is fed to the boiler, this block superheater. This block is called superheater. The purpose of superheater is to remove the moisturized steam and bring into a hot steam or wet dry steam. So, the superheater is, it converts the wet steam into dry steam. Why we need only hot steam? Because if we allow the wet steam into the turbine blades, the turbine blades will get rusted up and the efficiency will be decreases. So, therefore, to increase the turbine efficiency and to avoid the corrosion of the blades, a dry steam is fed to the turbine blades. So, therefore, from the superheated or dry steam is fed to the turbine. In the turbine, the steam energy is converted into mechanical energy. That mechanical energy is transferred to the generator through the coupling system, where in the generator the electrical energy is converted and given to the transformer through the switch and circuit breaker to the bus bar and various switch yards. This is the second stage of the steam transfer or getting the electrical energy. The third stage is, after converting to electrical energy, the steam will be wasted. That means, after introducing the steam with high velocity or high pressure into the blades, the turbine will be rotating, it converts the mechanical energy. But the wastage of steam, if we allow into the wastages, it will become a losses. Therefore, instead of wasting this steam, it will be fed to the condenser. From the condenser, again it will be fed back to the boiler to increase the boiler efficiency. So, let us see through this picture.